Hello and welcome back. So in this example here, I have the original sim on the left, and then using some volume VOPs in SOPs without doing any sims, I was able to add all these interesting details. This is something that is called volume displacement that generally happens, or we can add at render time. I personally don't do that. I don't add anything at render time, and I prefer everything to be baked into the sim, and we'll go into more details as to why is that. Now, this technique is really cheap, and I don't have any extra fields. It's just the density. This is one method that we can use to do displacement. Later in upcoming weeks, I'm going to show a more accurate method that doesn't require any rest fields. And as a side note, what in Smoke Solver, Houdini has an option to create rest fields, and what this is it's basically two vector fields that represents the position of the voxels at a specific frame that then gets advected for 15 or 25 frames. And you have two of these. You have rest 1 and rest 2, and each they are interleaved every 25 frames. And the reason for the interleave is because the more this field gets advected, the blurrier it gets. So it needs another one to pick up the rest of the 25 frames where it's not so blurry, and then there is a value that blends between these two channels to create an interesting or a stable UV coordinate in the volume. We're not going to be doing any of that because we don't. I don't think we need to generate two volume fields two vector fields to create a UV coordinate on the volume. I mean, the main purpose of it is to create a noise that follows through the mesh, the volume, basically. And we have a different technique that we're going to use. So this is the original sim, and this is after manipulating it in VOPs, using volume VOPs. And you can see we're getting a lot more details now. You can see the actual voxels are being pushed away. We're affecting it to the voxel level, and this is a little bit dangerous. We don't want to do that. We want the noise to always be at least 2 or 3 voxels, and so that we don't start getting jittering in the volume and in the sim. We don't want to see a floating voxel with just one value in it. We don't want that. But basically, this shows the technique, and I'm going to explain it here, and then we're going to start learning how to add it in DOPs, and it's going to look much better. Cool. So let's see. So I have a volume here, and this is something we've done in week 2. And I'm going to create a visualizer. I want to see how detailed this is. I'm actually going to remove all the other fields. I don't need them. So I'm just going to isolate the density. Okay, and here I'm going to set it to 1024. It may take a few seconds for it to display. It depends on the resolution. Cool. So this is how much. This is basically the highest resolution that we can display in the viewport at the moment. And you can see we're getting a lot of cool details here. There's a lot of interesting noise and patterns, but at the top here there's not so much. There's only these big blobs. And why is that? Is it because the volume is low res, or is it because something else is missing? Well, most of the time the resolution of the volume is not the problem. You can see we have 51 million, and this is a lot of data. Now let me show you. Let me prove that to you. I'm going to create a volume VOPs. And we're going to do a simple volume displacement on this and try to use a superfine noise to see if we can get interesting details out of this 51 million voxels, or if the volume is low res and we don't have enough data to actually do that. So volume sample, and let me disable the cooking. The viewport adds to this, so I'm gonna turn it off, and then let's connect the position and generate the noise. In this case, I'm going to create an anti-alias noise. I'm going to add that to the position. And we want to sample the density just to be sure. And let's expose these guys. Okay. Let's go back up. I'm gonna turn this off for a second so it's faster to work with. And let's destroy this. Set it to 10. Sorry, I need to connect this here. Okay, and let's set this to 3D noise. Okay, cool. So let's move this guy up, and let's take a look at this in a high resolution and see what kind of details we get. Okay, so the noise is too small to the point that it's pushing the actual voxels, and this is the stuff that I was talking about. We don't want that. We want the noise to always be at least 2 or 3 voxels in size. So I'm gonna copy this and paste it on the other channels, and let's start with 0.01. It's gonna take a few seconds for it to compute. Okay, let's try 0.1. It's taking a few seconds for it to display. And there you go. Now we have volume displacement. We are adding more details to this. Let's try and push it to 25. Sorry, 20. I put down 20. Okay, so we can add more details without changing the volume resolution. There is enough voxels for us to work with. The main reason for this being really low is not the resolution of the volume, it's the data that is coming from that is in DOPS, sorry. And primarily the velocity field doesn't have enough information, doesn't have enough details to disturb the density field. And we're going to be creating our own volume field, our own Vel field that we can use to disturb the density field in a very interesting way. And we're not gonna recreate what the gas turbulence do, because that one it's gonna generate a noise that swims through the volume, or a volume that the volume will swim through the noise pattern, and we can see that. We're going to generate a volume with noise that stick to the surface like this. You can see it's not affecting, it's not distorting the volume in a world space, it's relative to the object. And based on the details, we're getting details that actually move and follows the curvature of the surface. And in this video, I just wanted to explain that the resolution of the volume is not really the problem. Sometimes with something like this, which is not really high, you can get a lot of interesting details. Now let me show this again. You can get a lot of interesting details. And generally with mid-res volume, you can get something really high-res in terms of details, as long as the camera is not super close up, or you don't have a fly-through where you're very far away from the explosion and then you have to zoom in all the way into the explosion. If it's mid to maybe something like this, depends on the resolution, of course, you can get away with mid-res volumes in general. And in the next video, I'm gonna explain the theory behind the volume displacement, and then we're going to start applying it in DOPS. Thank you for watching, and see you in the next video. Bye-bye.